the next one?
If you invest $700 today in an account that pays 6.5% simple interest annually, how much will be in your account after 8 years?
Actually, this question is a very tricky question because it says that the account pays 6.5% simple interest annually. It doesn't say that it's going to pay 6.5% compounded what? Annually. So simple interest annually, not compounded what? Annually. So therefore, we cannot really use the regular future value equation, right? Because if we say compounded, that means that we're making the assumption that we have interest earning what? Interest. But here, we do not want interest earning
Interest.
So therefore, the answer is, are you ready?
8 equals 6.5.
So it's still a future value, but using simple interest rather than compounding interest. So it's going to be the present value, which is the initial investment plus the simple interest, which is the PV times the R times the N, right? So then what is the principal here?
700.
It's 700 plus the simple interest, 700, times the rate, which is 6.5%, and then times the number of years, which is 8 years. Right? And then we get 700 plus, what is the simple interest?
3,640.
What is it?
3,640.
364.
So it's 64?
364.
Oh, 364?
Yeah.
Is that what you said? I thought I heard 1,000.
360.
Right, because it's 700 times 0.065 times what? Is that what you heard? Did you get 64?
Yeah. Yes.
Oh, sorry, 364?
Yes.
So then when we combine those two, 1,064.
64.
So that would be the future value with assuming simple interest annually, right? Now for the exam, you also need to know how to compute the effect of compounding, right? Remember that one?
Total interest minus simple interest.
Very good. So compound interest is total interest minus simple interest. So yeah, if you have a question on what is the effect of compounding, that means I'm looking for compound interest, right? Right, so again, so compound interest, two ways to get it. It is total interest minus simple. Or another way to also do this is to say that it is the future value with compound interest, right? Minus the future value with what? Simple. That will also give you the answer. Next. Actually, 22 is fairly easy. What are the three areas of corporate finance? Capital budgeting, capital structure, and working capital management, right? Are you okay with that one? And of course, you need to know what each area is about, right? I think you do, right?
So beyond just listing that, we need to describe it.
Because you never know.
Okay.
That's what we hear, when we come to a review session and then we do a little more. So you need to know, and then I tell you, you need to know what capital budgeting means, you need to know what capital structure means, you know?
So we have to write that down?
Well, for this here,
This question?
for this question, no.
Okay.
For this particular question, you don't have to, but you never know. On the actual exam, the question could be different. Or I could explain what capital budgeting means, you know?
Yep.
So capital budgeting is essentially what projects you're gonna accept. Capital structure
What
is,
long-term project are you going
right,
to accept?
capital structure is gonna be, what's gonna be debt, what's gonna be equity.
That's right. How are you going to finance those
And the
long-term
final one
projects?
is managing your cash on the short term
Exactly.
basis.
That's right. Very good. He knows his stuff. Okay. Next, 23. Actually, 23, really interesting question. This one is kind of based on the amortization problem that we talked about earlier, right? This one is more the constant total payment case, right? Who wants to read it?
$10,000 is borrowed to be repaid in 4 equal annual payment with 8% interest. Approximately how much principal is amortized with the first payment?
Okay, so how much interest is amortized with the first payment? So basically the question is, what is the first principal payment, right? That's another way of saying it. So first, let's get that constant total payment, right? So this is how you would do it. I know that my payment will be such that the 10,000 will equal the payment times the present value interest factor annuity, right? Which is 1 minus 1 over, what is the rate? 80% to the power 4, because it's only 4. We only have 4 equal payments, right? Over 0.08. And then we solve for PMT. If you go to your financial calculator, what is N for N? A for I, right? And 10,000 for PV. 0 for FV. 0 for FV, because you, at the end, you fully amortize the loan, right? So therefore, we compute now what? PMT. Because after all, PMT is the only unknown in this equation. Do you see this?
Yep.
And then, of course, PMT here on the calculator will give you a negative number. Will be a negative number. So what is that? Negative,
3,000.
you say 3,000?
19.
19 point something? 2.8.
2
That's
0.
it. 2.0. Okay. So here, I said, well, that payment is about 3,019. Do you agree? Now, do we have 3,019?
Question?
No. So does that mean it's wrong? Yeah.
It did say that the 8% is the annual rate.
That's right. That's what we did. Annual.
No, it did not say.
What?
It did not say in the question that it's 8% annual rate.
Annual payment is 8% interest.
Oh,
Well, actually,
sorry.
It
didn't see
says,
that.
it's to be repaid in 4 equal annual what? Payments. But I think I understand her question. Let me tell you this. In time value of money, every time you are given a rate, unless it is really specified, if not specified, if you are given a rate, it is an annual rate. Very, very important. Okay. For example, if I say, 8% compounded monthly, it doesn't mean that the 8% is the monthly rate.
Right.
It is the 8% is the annual rate, but that's being compounded monthly. Okay?
So what is that?
3.
Now, but we're not done, because that's the total payment, remember? So this one has a component which is interest, and a component that's what? Principal. Now, the component that's interest, very easy to get. Why? Because what is the interest rate? It's 8% times
10,000.
10,000. What is that? So the interest payment would be the 10,000 times the 8%, right? So what is that? It's 800. So therefore, if 800 is going to interest, so therefore what must be going to principal? 2,200 and what? 19. What's the answer?
B.
B.
Huh.
You see this?
Yep.
Now remember, this approach is constant what total payment. And then we have to, separate this into interest payment and principal payment. Next, 24.
Papa Roach Exterminators Inc. has sales of 432,000, cost of 210,000, depreciation expense of 25,000, interest expense of 8,000, and a tax rate of 35%. What is the net income for this one?
So are you okay with this one, or what do you want to do?
Pretty straightforward.
Just follow the income statement.
Yeah, this is pretty much the income statement, but are you okay with this?
Yeah.
Are you sure?
Yeah.
Sure.
I'm sure enough.
Okay.
Yeah.
$25.
What is the present value
You
of?
do the next one. All right, go ahead. Go ahead.
What is the present value of an investment that promises to pay you 2,750 in 5 years if you can earn 6% interest compounded annually?
See, the 6% has to be an annual rate, even if it had said compounded what?
Monthly
Monthly,
or daily.
or daily, or continuously. It's always an annual rate. But except that here, because of the term compounded, we're assuming compounding interest. So let's do that. So it's the present value. So it's stated. Actually, this one is not bad, right?
Right.
2750. This is clearly a single cash flow problem, right? And then divided by 106, raised to the power 5. I know that so what's the answer for 25? 2054.96. See, the question 26, some people will be confused with that one. It says, find the present value of the following annuity, 300 per month for 6 years at 15% simple interest. Now here, I'm not saying that we are going to earn 15% simple interest annually. That's not what I'm saying. I'm just saying that the simple rate is what is 15%. But I'm not saying that that the investor is going to earn this percentage simple interest annually. I didn't say that. I didn't say that. Again, remember earlier there was a question. Let me go back to the question that we did. I think that was question 21. You invest 700 today in an account that pays what? 6% simple interest what? Annually. That's not exactly the same question. Right? So here I didn't say that the account would pay 15% simple interest what? Annually. I'm only saying that the simple rate is 15%. You know what that means? The APR is. Because the APR is a simple rate. Did you know that? Because again, remember, the APR is the rate, is a rate that has been annualized using what? Simple interest. The APR is a simple rate. The EAR is what? A compounded rate. Does that make sense? So, but when we use the EAR, we still use it in the compounding problems. Except that itself, it is a simple rate. Do you understand that now? So basically, this problem is really find the present value of the following annuity, where the interest rate is really 15% compounded what?
Monthly.
Monthly.
But then, so we divide it by 12.
That's right.
And then we multiply it times how many years?
Very good.
15,
Very good.
6 years.
So the fact that it's written 15% simple rate does not mean that we're going to do a problem using simple what? Interest annually. That's not what I'm saying. So it's a different type of problem.
So your 15 is capital R.
The 15 is the capital R. It is the APR. Is that clear? Do you see the different, the difference between this one and the other one? The other one was, okay, an account that pays 6% interest annually. Anyway, let's do this one. So it's the PV of an annuity. And the reason why I mention that is because students always get confused with this one, especially after doing the other one. So the present value of the annuity is going to be 300 times 1 minus 1 over 1 plus the rate, which is 1/5 over 12. Raised to the power. How many years? 6. 6 times 12. That's the best way to write it, right? And then divided by the rate, which is 0.15 over 12. Now, and then of course we go to the calculator to do it. What is my N? 6 times 12, right? 72. What is my I? Well, 15 divided by 2. You could also do that on the calculator, right? You could do 6 times 12, whatever you get, and 15. By the way, 15 divided by 12, whatever you get, you do what? I. And sometimes that's the best way to do it to avoid what? To avoid rounding. For example, if I tell you the rate is 7%, right? And then if you do 7, why don't you try, what is 7% divided by 12? 107 divided by 12. I just wanted to make a point.
0.5.
Divided by 12, right?
533.
So basically, it's going to be a number that would never end.
Right.
Technically, right? It's going to be 0.05 833333333, right? So which means that if you enter that number yourself on the calculator, then there will be rounding. That's the point I was trying to tell you.
Right.
So to avoid this, all you could do is you could do, okay, 7 divided by what?
12.
And then you will not round it. Is that clear? Instead of saying, oh, that point, what was the rate again? I think it was like 0.8%, right? Actually 0.58% or 0.58333%. Instead of saying that, just use 7 divided by 12 equals whatever you get, I. And then so that the calculator will store everything. Because if you do it yourself, it's rounding. And the final outcome would not be exactly the same, right?
I have a problem, and I think I still have it. I'm not exactly seeing why it's so. When it says simple interest, simple rate, I thought I'd take 300, multiply it times 6 years, times 12. Then I'd do simple interest, 600.
Yeah, but that's what I was saying. Here,
Yeah.
we're not doing, the problem is not really saying the account is earning simple interest.
Oh.
That's
okay.
what I was trying to say.
Yeah, that's what I don't see. How do you know that?
Well, how I know that is because it's not saying that it's earning simple interest annually. It doesn't say that. It simply said that the simple rate is.
Oh,
Could you
okay.
define simple rate?
Well, the simple rate is the APR.
Okay.
You understand that? The simple rate is the APR. I mean, when we did the APR, my definition of the APR, it's a rate that has been annualized using simple interest. So the APR is a simple interest. However, we still use it in time value of money computation.
And
For
you know it's
example-
compounding monthly because it's a monthly annuity?
Because it says, yeah, exactly. It's a monthly annuity. Thank you. That's how you know.
If it was simple interest, would you multiply 300 times 6 times 12 plus 300 times?
That's right. You could do it.
Okay. But that's not the case.
That's not the case.
And the reason I know that,
And that's why I'm talking about it, because a lot of people are confusing
Right.
this with what we did in question
well,
21.
we just have to know that simple, the APR is a simple rate as well.
That's right. That
And
capital
unless you
R.
specifically say that it's being, when you
The
say it's
account-
compounded, we assume.
If I say the account is earning 6%
simple.
simple interest annually, it's earning. But here, I didn't really say that, right? I didn't even say it was earning anything. I only said that the simple rate is, right? So therefore, we have to treat that rate as being the APR. And then, when we use the APR, this is how we do a future value, like basic future value with APR. Right? I don't know if you remember. Remember that? That's how we do the problem. In other words, we're going to get the rate per period times the number of what? I mean, a raise to the power number of
Compounding.
compounding period. That's how we did it, right? The APR itself is a simple rate. As opposed to EAR, which is a compound rate, or compounded rate. However, if we want to use the EAR, as we saw before,
Put it, annualize it.
exactly, we have the exponent has to be annualized, and then we say it was the number of fractional variance. Remember that one? Yeah. Okay. So that's the difference. So here it says the 15% is a simple rate. But not that the account is earning interest, simple interest annually. That's the difference. Even if you go to 25, the 6% is a simple rate. But that has been compounded what? Annually. See, 6% interest compounded annually, it's also a simple rate, right? Do you understand this? Yeah.
So what is the answer?
So, and then with the answer, and then you go to the calculator, you have 6 times 12, and payment here is 300, right?
Like 21,000.
And then 0 for future value, and then I compute PV, right?
Right.
14,187.74.
14,187.74.
74.
Is that what you have? And of course, instead of the present value of the ordinary annuity, it could have been the present value of the annuity due, right?
Times 1 point.
Times 1 plus 0.15 divided by 12, right?
Yes.
1 plus R. which is the period rate, right? It could have been a future value of the annuity, right? This is where I could change the questions on that one. It could have been also a future value of the annuity due. So basically, that's the best way to study. When you see a question, try to imagine other possible scenarios. Okay, maybe the answer could be this, it could be that. If it is this, how do I handle it, If you're able to do this, then that means you're ready. What?
Ready for what?
Ready
For
for
the
the exam. Next, provide one example of a pure discount loan.
Treasury bill.
The treasury bill. Or a zero coupon bond, right? Or simply a loan involving what? One lump sum. That make sense? 28 is fairly easy. What is the present? Hopefully you will agree with me. Because sometimes when I say it's easy, then some of my students say, oh yeah, easy for you. Hopefully you'll agree with me, right? What is the present value of a perpetuity of 100 per year if the appropriate discount rate is 7%? By the way, did I specify when the first period was made?
No.
No. So if I don't specify, which one is it? It is the ordinary. Right? But again, remember that on the exam I could change this question to perpetuity due. And of course, if that's the case, then I have to say that the first payment is made
The beginning.
immediately, or today, or tomorrow, right? So here it's PV is, what is the annuity, what is the constant amount?
100.
Is it 400?
100.
Oh, 100, sorry. What is the rate?
7%.
And that's it, right? That's the end.
I have a question.
Go ahead.
It says like if the payment is made today or immediately, that means the question is overdue.
Now here, we didn't really have to say anything because I wanted you to solve the problem as if it were an ordinary perpetuity. So if I don't specify it, then that's what I mean. Okay?
Yeah.
So where are we now? 29. Now converting an annuity, which is really an ordinary annuity, to an annuity due, increases the present value.
No, it increases the payment.
What do you mean, increases the payment?
Oh.
Again, I repeat, converting an ordinary annuity to an annuity due increases what?
The present.
Its
Yeah.
present value.
Because there is multiplication 1 times 1 plus r.
Who's present?
Well, the present value of the annuity. So let's say, if I were to compare the present value of the ordinary annuity versus the present value of an annuity due, i.e. I convert my ordinary annuity to an annuity due,
Oh, it does.
what's going to happen to the present
That's
value?
because
Yes.
Of
you
both,
get the
right?
money
It's
sooner.
increase.
Again, so we start with ordinary,
Yeah.
converting the ordinary annuity to an annuity what?
Do.
Due. Will increase the present value, that's true.
Okay.
Yeah. Well, because, what is the present value of this guy? Right, it's PMT over times 1 minus 1 over 1 plus R to the n, right?
Yeah.
Over R. Do you agree?
Yes.
What about the PV of this guy?
Times
We multiply by what?
1 plus
1
r.
plus R. So therefore, converting an ordinary annuity to an annuity due will increase the present value, as well as increase the future value.
I thought-
We are increasing on period.
Why? Because the stream is moved 1 period. So So therefore, if you move it one period to the left, its PV is bigger, right? Or it's, if V is also bigger, because when you take it to the future, you have an additional period. Does that make sense? So if you go to the future, you have an additional period because you move the string one period back. To the future, you have one additional period, that's why 1 plus R. Even to the present, you're also earning more interest, right? Because the string is shifted, one period. So that each payment will have a higher present value. Do you agree? So therefore, yeah, go ahead.
Could you think of it as well as taking the last payment and putting it at the very first, and then therefore it's like discounted, and so instead of being worth less value, it's worth more value because you're getting it initially.
Which one? I think I want to understand what you're saying really well, because I don't want you to think that there's an additional payment when we do it.
No. They're the same number of payments. Everything's the same, except you take the last payment for the annuity, for a regular annuity. And the annuity due, you put it in the very first position. So instead of having had
That's right.
discounted, that's
You
the
can also
total
say that.
value difference.
But this is,
But I still prefer to say that you were shifting
Yeah,
the stream.
okay.
Right, because it is that stream that's gonna earn an interest for an additional period.
Right,
The whole
each
thing.
one of them one period, and altogether it will be.
Exactly. So overall, it's really 1 plus R. I prefer to say it that way.
but this is assuming that the payment is constant. Say, I'm
But it
paying,
is, payments are constant,
how about like,
because that's why it says annuity, right?
oh. Oh, so I was.
Do you agree? Because if it says annuity, the payments must be
So
constant.
I was thinking, see, if you, okay, you have to pay off like $3,000 in 3 years. Then each year you pay like $1,000, say $1,000, the end of the year. But if you pay it at the beginning of the year, then you might need to pay more.
No, actually, that's not what this is saying.
Okay.
Yeah, I understand, but this one is saying that if you shift, if you go from an ordinary annuity, which means that you have exactly the same payments,
Okay.
the same number of payments, except the exception is that you're gonna start in period 1. That's the ordinary annuity.
So when you say an annuity, that means that the payment amount, the amount of the payment is like certain.
Constant.
Annuity due starts at period 0.
Exactly. Annuity due will start at period 0, but end at period n minus 1.
Mhm.
So you still have the same number of payments. And then the ordinary one, you start at period 1, but you end at n. So again, that stream is shifted 1 period. So therefore, you shift it to 1 period to the left, right?
Right.
So therefore, its PV must be higher by a factor of 1 plus R. And it's a future value. Why? Because you're gonna earn, if you compound, you're gonna earn interest in additional period.
Right.
Again, 1 plus R. Does that make sense?
Yes.
So therefore, I could change this statement. Instead of saying increases the present value, I could also say increases the future value. That will still be true. Right?
Right.
Who wants to read the next one?
Assume the total expense for your current year in college equals $15,000. Approximately how much would your parents have needed to invest 21 years ago in an account paying 6% compounded annually to cover this amount?
Are you okay with this one?
Yeah.
Okay. This is just the present value.
Right.
Next one.
Find the future value of the following cash flow stream if the appropriate discount rate is 8%.
Okay. Yep, find the future value of the following cash flow stream if the appropriate discount rate is 8%. Now here, when we say future value, it's going to be the value as of the terminal year. What is the terminal year here? 5. And that's how you would do it.
To compute the future value of each cash flow.
That's right. So then my future value, so then I take the first one and then I bring it to year 5, right? So it'll be 500 times 108 raised to the power 4. Do you agree?
Right.
Plus 200, 108 to the 3. Do you agree? plus 450. 108 to the 2 plus 450, 108
Power of one,
to the 1, and then plus
150.
150. That's how you show your work, right? Now, to get the answer, you could use again the numerical solution, i.e. you could simply enter those values as they appear into your calculator and then they get the answer. Or, if you want, you could also use the cash flow register. Right? But then, if you want to do that, then there will be 2 steps. Because you have to do the PV first, and then whatever you get, you multiply by 1 plus r raised to the power 5, right? Does that make sense?
So when you do the cash flow with the calculator, so CO 0 will be 0.
That's
and
right. It will be 0.
1 will be.
Yep. It would not be 0 if I had an extra period here. Let's say if I, under year, if I had said 0, the cash flow that appears under 0 will be the CF naught. But here, there's nothing in year 0. So that's why it's 0.
Yeah, and when we so we'll get a MPV, and when we calculate FV with the formula 1 plus r to the power of n, is n going to be 5 or
Yes.
4 here?
5. Why is that? Why is it 5? Look at the terminal here. What is it? It's 5. Now, I think what you're saying is, I understand what you're saying. I could have also done this, right? And I could have started at period 0 here. I could have said, I could give you an additional period where the first one is year 0. If that was the case, and this one, let's say at t equals 0, I had, let's say, 600. That's the additional one, right? Then I would have here 600 times 108 raised to the power 5. That's the difference. And then going to your cash flow register, there will be something at CF naught. 600, that's the only difference. But here, because there's nothing at year 0, it means that there's nothing for CF naught. Therefore 0. Right? She just gave me a very good idea. Maybe it's to add the cash flow in period 0. You know what I mean?
Tricky.
Right? But it shouldn't really matter. You know why? Because when you go to the cash flow register, you simply
Put in what's there.
We're in the
Exactly.
0 anyway.
Exactly. So you look at the timing. If the first one is in period 0, then there will be something for CF naught.
But this is what you want to see,
That's right.
this formula.
That's right.
Okay.
And then after that, whatever you got. You know? If you want, you could use the cash flow register. If you want, you could use the numerical solution, i.e. enter those as they appear, right?
How do you grade if the formula is right and somehow there's a mistake or it was entered wrong, so the answer is wrong, but the formula is
Well,
right?
I'll give you very easy to answer.
Uh-huh.
Let's say the question is worth 4 points.
Yes,
Then you definitely get half
for showing the work.
for showing that work.
Okay,
And then the other 2 will be for the work, for the
answer.
yeah.
Okay.
You know, depending on my mood at that time. I could even give you 3 points for showing the work, you know?
Oh,
Because,
you get the concept.
exactly.
Okay.
You know what I mean? So
Yeah.
I could even help you more if you show your work, you know?
Uh-huh.
All right?
Yep.
Next.
If a loan carries an interest of 1.5% per month, what is the effective annual rate?
Would you know how to do this?
Yeah.
So here, 1.5% per month is really the APR over
12.
12. Right?
Right.
It's already that APR over 12. So therefore, if you compute it, then you simply do 1 plus EAR is really 1 plus that 0.015 raised to the power 12. That's it. Because this is already the APR over M, right?
Right.
Do you see that?
Right.
I was saying that the 1.5% is already the monthly rate. It's already that APR over M. So you don't need to touch it, right?
So is that the equation you want?
Okay.
Yes.
Can I use a different equation?
Well,
Can I
it
say,
makes sense, yeah.
Can I say present value equals,
Present value, why would you want to do
I
that?
put in values for one for each of them. And then I get I get the future value for one
Well, that's
period.
if you, well, you can only do that in producing the final result, yeah.
That's how I get it.
Yeah, I mean,
That-
yeah, because what he's saying is, when he looks for the outcome, for the answer.
It's
Then you-
1 point, yeah.
Exactly, so this is what he says. So when he goes to the calculator, he can
Yeah.
also say that the PV is 1, right? So i.e., he's saying that 12